Yeah.
And this isn't related to that, but in the booklet, for the question where it says find the first four terms of the sequence, they start out with A, F, N. That's the same as U and N. It's just another.
They start with, sorry?
It's A at N equals N squared divided by 2N plus 1. That's the same as U and N, right? It's just.
Think so.
Yeah.
Yeah, I'll have to have a quick.
Right here, it says A.
Oh yeah, AN. Sorry, yeah, on that sheet I gave you it says A little n. That's the same. Yeah, different people use different notation, but we need to stick with the UN. So let's just have a quick look. How do you apply an explicit formula that's a fraction? So, for instance, if I told you that UN was 2n plus 1 over n squared plus 2. Right? So that looks like a complicated sequence. Okay? How would you find the first 5 terms of that sequence? Yep.
You would replace N with 1, so you do 2
So I do 1, 2, 3, and so on. Yeah, go on then, so do.
So you do 2 times 1 plus 1
Yeah.
over 1 squared plus 2. And that would just be 3 over 3, which is 1.
3 over 3. Okay? Which, yeah, it's quite a nice one to say that is 1. That's an important thing, actually. Because the first term is 1. The second term, though, would be 2 times 2 plus 1 over 2 squared plus 2, which will equal 5 over 6. So that would be a fractions. This one, 2 times 3 plus 1 over 3 squared plus 2, which will be 7 over 11. Okay. Alright, so it's always quite easy to use the explicit formula. What would be quite difficult in this case would be to write the recursive formula to tell me how it goes up one by one. So you probably wouldn't be asked to do that. However, what you might be asked is to go the opposite of what we've just done. Okay. So the opposite to what we've just done is to write the explicit formula I gave you sequence. Sorry, if you're still writing, let me know. Okay. So, for instance, if I gave you a sequence as 3 over 5, okay, is the first term, right? And then I'm going to give you 7 over 26. I'm going to 11 over 37. Oh, sorry, no, I've messed up. I want this one to be that should be 10 and that should be 26. Sorry about that. The next one, you might see what I'm doing now then. So that would be 37. Okay? So there is a sequence. Okay. There is a sequence which is fractions, and it could potentially look very complicated. So, what we've got at the moment is when we do a sequence and we try and find the explicit formula, what we try and do is work out what it goes up by. So how do I get from 3/5 to 7/10? How do I get from 7/10 to 11 over 26 and so on? But when we've got fractions, that can be really quite difficult. So any ideas? What would we do instead? Yeah?
I'm not 100% sure, but I realized on the top they go up to fools.
Yeah. So I think that's what you're noticing. Like when we were doing the answers, we can actually treat this as two separate sequences. So what we're going to look for is a UN on top and a different UN. Maybe we would call that AN, using the notation. And we actually treat it as two separate ones, one on top, one on bottom. Okay, rather than thinking of the fractions as their own individual thing. I don't want to convert them into decimals, that just makes rounding and all that kind of stuff, which makes it inaccurate. We treat it like two separate sequences. Okay? And I think you already said, what's the top sequence? Okay, so the top sequence would be 4n, because it goes up by 4. So it's plus 4 every time. And then minus 1. Is everyone happy with finding that 4n minus 1, yeah? This stage, I hope if there's an issue with finding that's 4n minus 1, let me know. Then we need to find the second one, the one underneath. So any ideas? See, actually, this brings me to something else I wanted to talk about with you, which is, it's not linear, is it? No. Is it going to be geometric? Well, geometric means it's going to multiply and get big fast. So 5 to 10 would be multiplied by 2, and if that carried on, the next term must be 20, and it's not, it's 26. So we would have 5, 10, 20, 40, and then so we were too big and now we're too small. So it's not geometric, it's not linear, so that would lead us to the conclusion it's probably, well, arithmetic is the linear one. So it's not arithmetic, it's not geometric, so it's probably going to be quadratic. Okay? It's going to be linked with the square numbers. Now, this leaves me something I wanted to talk about. How would you find the rule for a quadratic? So I'm going to rewrite it over here. What was it? What was it again? 5, 10, 26, 30. So you have a method for doing it, which will work absolutely fine. I have a quicker, easier method for you, but let's go with the method you've already got so far. So I'm going to write, well, n is 1, 2, 3, 4. Who would like to give it a go? Who wants to talk me through it?
Unless you want to talk.
Go for it.
Oh, that would.
Well, it's bound to happen if you're going to give someone else, isn't it? Go on, what's the first step?
Well, the first step. What's the rule?
So we think we're going to have a quadratic, don't we? So we think we're going to have something n squared plus something. So what's the first thing? Figuring out the something n squared. So how do I do it?
First thing would be figuring out the rule. I'm just going to maybe like plug in the 1, since like the a is.
Well, we don't know yet. How many n squareds have we got? How do you figure that
I
out?
don't know.
Anyone want to help him? Jump in? How do you figure out how many n squareds?
To find the second line of difference.
Yes, need to find the second line of difference, don't we? So the first line of difference is plus 5 plus 16 plus have I messed up again? Oh, do you know what? I've messed up completely. Let me something. I'm going to change it because I did something that wasn't going to work. I'm sorry for your notes. It's going to be 5, 10, 17, and 26. I'm very sorry about that. Now it should make it easier, shouldn't it? So now it's plus 7 plus 9. Okay? Sorry about that. My fault. So now we find the second line of difference, which is plus 2.
Yeah, n squared plus 1.
So it's going to be n squared. Definitely n squared. Only one of them. All right? Now, here's what you've done before. Well, this is what I'm trying to figure out, but we've decided it's n squared, so I'm going to write out what n squared would be. So n squared would be 1, 4, 9, 16, and what I have is 5, 10, 17, 26. So I've got n squared there, and I've got n squared plus... Okay. So this is the line I want to know. We've decided it's 1n squared. Good. But we're not where we need to be. So how do we get from where we are currently to where we need to be? So that gone.
You can figure out how you have to answer it. Answer it plus.
Okay. So that would be plus 4 plus 6 plus 8. So that changes. So it's not just a plus a number. So this is like the very first one we did, where it's not as simple as n squared plus 2, n squared minus 3. We're going to have another part to it. So we have a sequence which is 4, 6, 8, 10. So that's a what type of sequence? That will be an arithmetic. So if we can figure out a rule for the plus what as an arithmetic sequence, that will tell me what to add to my rule. Okay? Is everyone with me? I hope I'm not losing people, yeah? Okay. So we've got another sequence then. So, sorry, plus 4. So what's the rule for 4, 6, 8, 10? So it'd be 2n, definitely, plus 2. Sure? Because n again is 1, 2 times 1 is 2, plus 2 makes 4. Okay, so we are looking at n squared plus 2n plus 2. All right? Make sense? It's it's at the highest end. It's at the difficult end of what we've been doing. So you might need to take a moment to think it through. But don't forget where we are. I know I wrote the wrong thing, so I'm going to go back over here and change these numbers, obviously, because they were wrong. So that will be 17. That will be 26. So my rule for this sequence as a fraction, so that would be n squared plus 2n plus 2. So I've done it 2 separately. So that, in a test, for instance, if I were to give you one like that at the end of your assessment coming up, you know, that would be checking, A, can you work with fractions? B, can you do arithmetic sequence? C, can you do the first stage of a quadratic? D, can you do the linear part that you have to add on to the quadratic? Like, that's a big question. There are lots of things going on. All right? So that's a tough one. Now, I do want to introduce you to something which is a slightly different way of approaching this bit that we're on. Oh, yeah, it's done that again. All right? Okay, a slightly different way of approaching this, the n squared plus 2n plus 2 bit. All right, Can anyone spot a quicker way of getting to n squared plus 2n plus 2? Yep.
Well, right off the bat, I realized that it was a square number. Like, well, it's not a square number, but I realized that 5, the closest square number is 4, is 9.
Yeah.
And I did like that was 17 over 60.
Yeah, I tell you what, spot on, right? Other people are struggling to stay attentive. So we need to make sure those that are struggling to do that, both of you. Okay. What I'm going to do is I'm going to rewrite it as, again, so I've got n being 1, 2, 3, 4. Okay. Don't write yet, just watch what I'm doing, and then you can write down afterwards. The sequence we had was what again? 5, 10, 17, 26. Okay? Now, what was noticed down here was that actually the closest square number to 5 is 4, and the closest square number to 10 is 9, 16, 25. So what we actually have is 5 plus 1, 9 plus 1, 16 plus 1. You notice that? Okay. So, we know it's going to be quadratic. Let me remind you, this is kind of a shortcut method. It's another way, but if you can do it, it could save you a few minutes working it out. So if you can spot the fact that actually it's just a square number, add 1 every time. The difference here, though, is it's not n squared plus 1, is it? That doesn't work. But what do we have? So what we actually have is I think that's narrow, it's this one squared. Got that? And actually, 5, I haven't written that one, but if I took 5 and squared it, you get 25. So, can you think of any other way of writing it? So it's not n squared plus 1, that doesn't work.
In brackets, n plus 1, in brackets squared, n plus 1.
Exactly. Do you all see that? Because you actually have to take the number from the next one up, then square that, bring it back. Okay? So to work out when n is 1, you actually add 1 to it, to the 2, you square that, add 1, and we get the 5. So is that the same as n squared plus 2n plus 2?
Yeah.
Have we got the same thing? Is everyone happy it's the same thing, or does some people just have no idea? Who has no idea whether it's the same thing or not? Okay, you're honest, good. So everyone else can tell me why it's the same thing. Cole, what would you do to show it's the same thing?
Well, I'm guessing n plus 1 squared would be n squared, right?
So we're going to look at, so n plus 1 squared would give you what?
N squared? No?
Just n squared. It will, the n squared will result from it, but anything else?
I'm not really sure.
Sure.
It will give you the plus 2.
So if I do that, what do I get? N squared.
Another plus 2. 1, 1, 2.
Yeah.
Any comments on that?
You have to expand the bracket.
Okay. When you square, by the way, what do you do to something to square it?
You multiply it by itself.
You multiply it by itself. So do you see how it can't be plus 2? Because that would be plus 1, wouldn't it? So actually, that's a common mistake, not the plus 2 actually, is to say it's plus 1, but what's missing? How do you multiply it by itself?
Oh, you write it again like n plus 1 in brackets, then n plus 1 in brackets.
Exactly. And we expand that. So we actually do the FOIL thing, yeah, which is n squared, that's that bit, plus n, plus another n, plus the 1 times 1 gives you the 1. So it becomes n squared plus 2n plus 1. Is everyone happy with what I did there? So the n squared, and then the 1 times the n is n, then the n times the 1 is another n, and then the 1 times the 1 gives me the plus 1. Okay, so that's that bit. So that is n squared plus 2n plus 1, and then I have to add the 1, gives me n squared plus 2n plus 2. So you can see they're both exactly the same thing. All right. But that is another way of spotting the quadratic rule. Okay, maybe quicker if you can get that. If you can't, if you just can't see where that came from, at least you've got the second line of difference, and finding the difference and so on. Any questions on what we just did?